Okay, hello and welcome to this online lecture for my HUP 112 Philosophy and Logic class, which I teach at LaGuardia Community College. So today we're going to be going over section 6.6 of our textbook, which is what we're using is Hurley, A Concise Introduction to Logic. Um, it's in the 13th edition, but really any edition would work for this class pretty much. Some of the earlier editions are somewhat different, but overall they're pretty similar and don't change except in the smallest little details. So we're going to be go ahead and going over that. So let's go ahead and get started today. I'm going to be sharing, how do I, you would think I know how to do this by now. Um, Whiteboard Classic. Okay, so this is our whiteboard here. Today we're going to be talking about argument forms and propositional logic. In order to do that, we're going to be introducing a new variable, which we call statement variables. So statement variables, as used in the textbook, include lowercase p, lowercase q, lowercase r, and lowercase s. And statement variables stand for WOFs, or well-formed formulas in propositional logic. So we're familiar already with the with capital letters, so A, B, C, etc. These stand for propositions or statements. And so A here would stand for some statements like Africa is a continent, or arrabbiata is a spaghetti sauce, or whatever uh, proposition that you may happen to want it to stand for. And we're familiar with forming conjuncts of these things and disjunctions of these things and implications of these things. And of course, negations of these things, etc. So we've been studying all these things using truth tables and getting very comfortable with that. But now our statement variables are going to allow us to talk about any well-formed formula whatsoever. And we're going to be able to specify the generic argument forms in this structure. So, for example, we'll talk about our first argument form here, which we'll say is modus ponens, um, abbreviated MP. This is Latin for in the mode of placing, I think ponens actually literally means. But what it's named for is what this first happens in the second premise. So if you know that P horseshoes Q, and you also know that P is true, then you're able to infer that Q is true. So notice we don't have the numbers over here. We're not numbering the premises because we remember that when we number the premises, what that symbolically stands for is that someone has asserted that proposition. But no one is asserting these propositions. These are statement variables being used to make a statement placeholder, which could be filled in any way. So, for example, an example of modus ponens might be A horseshoe B as a first premise. Second premise would be A. Conclusion would be B. But of course, you could have A dot B horseshoe C wedge D as a first premise. The second premise might be A dot B, and the conclusion would be C wedge D. You could even have something more complicated, like maybe you had A wedge B horseshoe C, horseshoe brackets A dot B wedge C. I'm just making this stuff up. So that might be our first premise. The second premise might be a wedge B horseshoe C, and then the conclusion of this would be A dot B wedge C. So all of these things that I've written here on the board can be seen to be versions of modus ponens with different assignments of the P and the Q. So for this first one right here, we have, so for this first one, we have the P term is being A and the Q term is being B. And if you substitute A and B in for P and Q, then this says P horseshoe Q, P, therefore Q. So that can be seen as a version of modus ponens. Now, this one here, you have the P term, which is going to be equal to A dot B. And you have the Q term, which is going to be C wedge D. And if you substitute P and Q in for these, then this one here says P horseshoe Q, and this is our P term again, and this is the Q term. So this is another example of modus ponens, and the same is true for this one down here. So this one down here, the P term is a bit more complicated. It's this A wedge B horseshoe C, and the Q term is A dot B wedge C. And so this is also a version of modus ponens, and any argument which can be interpreted as in this way is going to be an example of modus ponens. Now, notice that this is very useful because if you have an argument like this and you want to do a truth table, you only have two propositions. So that's a small truth table of 4 lines. By the time you're over here, you have 1, 2, 3, 4. So that's 16 lines of a truth table. And of course, there are no limits to this. So if you had 5 propositions, that would be 32 lines of a truth table. And if you had 6, then that would be 64. So, for example, if we had something very complicated, so to take another, just to kind of try to nail this home here, if you had something very complicated, like your first premise might be having a curly bracket, and then it might say A wedge B, in parentheses, horseshoe, and then a bracket, and then a C dot D, let's say, triple bar, E horseshoe F. Okay, so that might be our first premise. And the second premise then would say A wedge B, and the conclusion of this would be C dot D triple bar parentheses E horseshoe F. So here we have 1, 2, 3, 4, 5, 6, 6 propositional variables. So we would need 2 to the 6 in order to the 6 lines in order to truth table this out. So that's 2 times 2 times 2 times 2 times 2 times 2, which I think is 64. So, and of course, the more variables that you have, then the more lines that you're going to require in a truth table. But if you can see that this is very simply a version of modus ponens where the P term is A wedge B, and the Q term is C dot D triple bar E horseshoe F. And so this says P horseshoe Q, and this is P again, and this is the Q part again. So if you recognize this, and we know that modus ponens is already provably valid, because in schematic form, it says if you have P, then you have Q. And we also know that we have P. So of course, we're going to have Q if these two are true. So recognizing that automatically shows us that this very complicated thing over here is valid, and we don't need the 64 lines or whatever of a truth table in order to prove it. We just have to recognize that it is an example of one of these valid forms. So that's what we're going to be doing today, is talking about 6 of these valid forms, and then 2 invalid forms that we'll talk about towards the end. And then we're going to go over the homework assignment, the starred ones, as we normally do. Now, in our textbook, they use lowercase p, lowercase q, lowercase r, lowercase s. If you're looking around online, if you're checking the internet for help or whatever, then you will see more often than lowercase letters like this, you will see the Greek symbols. So this is phi, this is psi, you will see a chi, and then alpha. Okay, so this is PHI, that's phi. This is PSI, that's psi. This is CHI, that's chi. And then this one is alpha. And these are Greek symbols. So this is the letter P. That's where philosophy comes from. It's a F. This is the letter also P. It's where we get psychology. So this is the F P, and this is the S P, so psychology, philosophy. Okay, great. This is chi. This is the Greek letter X, and this is alpha, the Greek letter A. So it's much more common to see phi, horseshoe, psi, and phi, therefore psi, written on the internet as opposed to lowercase p, horseshoe, q, lowercase p, therefore lowercase q. These symbolically mean the same thing. I think our book uses the lowercase letters just because they feel like maybe it's easier for students to grasp. But I think it's somewhat more difficult because these ones, in my opinion, are much more standard. So if you are looking around online and you see something like phi and psi, then just know that these are statement variables. Unless, I mean, phi is used for a lot of different things. But in propositional logic, phi is used for a statement variable. So that'll help you if you come across any of these. I will stick to using the lowercase p's and lowercase q's because that's what our textbook is doing. Okay, so we've already said we have modus ponens. So just to write that out again, it's called modus ponens because it was discovered in the Middle Ages, or I think around 100 or so. I don't know. I don't know the history of this stuff as well as I should, but I'm pretty sure it was a guy named Chrysippus who maybe lived 100 around the year 100. I could be wrong about that. Maybe that's not exactly the Middle Ages, but it's definitely towards the end of the ancient period of history. So don't worry, we won't be worried too much about the dates. I'm just explaining why it has this Latin name, modus ponens. And ponens, ponens, literally in Latin means putting or placing something. So what it's really supposed to be like in the mode of asserting the antecedent. So you've asserted a conditional statement, and then you said, look, if P then Q, and also P is true. So therefore we know that Q is true. So it's this second premise that the modus ponens gets its name for. Related closely to this is another one that's very well known, which is modus tollens. Oops, why did I cross that? That's an L. Tollens. And tollens in Latin means taking away, or one of its meanings is removing or taking away. So this is in a mode of taking, this is in a mode of placing. And modus tollens says if you know that P horseshoes Q and you know that Q is false, then you know that P is false. So sometimes people wonder about this one. It's pretty easy to see that it's valid if you think in terms of necessary and sufficient conditions. So remember, we had a whole section on this earlier in the class, so you can go back and check that video. But this statement here, P horseshoe Q, tells you that Q is necessary for P. So if Q is necessary for P and you know that Q is false, well, then P has to be false because Q is necessary for it. So, and modus tollens can always be rewritten as a version of modus ponens. So we know that P horseshoe Q is logically equivalent to tilde Q horseshoe tilde P. So these are logically equivalent. And then the second premise here would say tilde Q, and the conclusion would be tilde P. So that's just a version of modus ponens once again, where we have this thing, tilde Q, horseshoeing tilde P, and then the assertion of tilde Q again. So modus tollens, if you don't really believe that it's valid, then recognizing that these are logically equivalent can kind of make you recognize that it is a version of modus ponens. Now, If you don't believe me, go back and look on the video on classifying propositions, and you will learn how to prove this. Truth tables will easily verify that this P horseshoe Q and tilde Q horseshoe tilde P are equivalent. Okay, so the next one that we look at is what's called a pure hypothetical syllogism. It's pure because all of the parts of it are hypothetical statements. Um, these other modus ponens and modus tollens are hypothetical syllogisms because they have uh, a first premise here that's a conditional statement or hypothetical statement, but the second premise and the conclusion are not. So the pure hypothetical syllogism says if you know that P horseshoes Q, and if you also know that Q horseshoes R, then you can conclude that P horseshoes R. So this one here, you kind of see that the consequent of the one statement is the antecedent of the next statement. So these kind of form a chain that allows you to go from P, if P to then R. So that's what the pure hypothetical syllogism is doing. Then we have our good buddy disjunctive syllogism. Disjunctive. We'll give examples of these in a second. Look at the assignments, which give examples of these in English. So disjunctive syllogism has to do with disjunction. Disjunction is our wedge operator. So this has to do with, it's not hypothetical. It says if you know that P wedge Q, and you also know that P is false, then you can conclude that Q. So disjunctive syllogism. What's interesting is just like over here, you could see modus tollens logically equivalent to a version of modus ponens. So is disjunctive syllogism, because it turns out that P wedge Q is logically equivalent to the sentence tilde P horseshoe Q. And then the second premise would say tilde P, and the conclusion would be Q. So if you don't believe me that tilde P horseshoe Q is equivalent to P wedge Q, then you can do a truth table on them and verify that for yourselves. So what's interesting is that modus ponens seems to be a very basic version of these. Now, of course, what I'm not telling you is that you could see modus ponens as modus tollens as well. If you flip it around, you get tilde Q horseshoe tilde P, and this thing would be you could use double negation on it. But let's save that. We'll get back to that later. But anyway, so what's interesting is that these all seem to be reducible in a sense. If you really wanted to, you could just take modus ponens as your kind of basic rule. And in a lot of logical systems, that is what is done. But in the system that we're learning, that's not what's done, because in the next section, we will be, well, first, after this, we're going to be looking at three valued logics, introducing a new truth value of neither true nor false, or both true and false. And in the next section after that, we will start to talk about natural deduction. And the so-called naturalness of natural deduction is exactly it lies in the fact that you're allowed these multiple argument forms as opposed to just reducing everything to some version of modus ponens. Okay, so here are four valid argument forms, which if you recognize an argument as fitting into one or the other of these, then you know right off the bat that it's valid. The last two that we will discuss that the book offers us, there's one which is called constructive dilemma. So constructive dilemma starts off with a conjunction in the first premise. It says, if you know that P horseshoes Q and also that R horseshoes S, and furthermore, if you know that either P or R, then you can conclude that either Q or S. So this is a dilemma, this is my version of an R, by the way. A dilemma is when you have two options, a dilemma. So one of these are the lemmas. And you have two of them. So you could have trilemmas, quadrilemmas, etc. But dilemma means two lemmas, so two options. So you might say something like, if we raise taxes, then the economy will suffer. If we don't raise taxes, then the government loses money. So either we raise taxes or we don't. Therefore, either the economy suffers or the government loses money. A simple version of constructive dilemma. So constructive dilemmas are very powerful argument forms, and they're often seen in political discourse and debates. Where someone says, okay, look, you have one of these two options, and each one leads to some consequence, so you're going to get one or the other of those consequences. You can kind of see it as a weaker version of two modus ponens because it's weaker because the conclusion is a disjunction. And if this were a debate class or a rhetoric class, we would discuss ways in which you would engage with these. There's something called grasping the dilemma by the horns, which is trying to prove the first premise false. There's something called escaping through the horns, which is to try to prove that the disjunctive element is false. So we're not going to worry about any of that stuff. But it does exist, and it is interesting and useful. Okay, so the last one that we will look at is what's called destructive dilemma. So destructive dilemma begins with a similar first premise where you know P horseshoes Q and also that R horseshoes S. The second premise, though, gives you a disjunction of the negated consequence. So if you know that not Q or not S, then you conclude that not P or not R. So this is like a two versions of modus tollens stuck together. So here's one modus tollens, P horseshoe Q, not Q, therefore not P. Here's the other one, R horseshoe S, not S, therefore not R. There you go. So, and of course you have the wedge here. So you only need one of these to be true in order for the conclusion to be true. So it's somewhat of a weaker argument in the same sense. These argument forms are not the only argument forms that exist. There are other ones. There are many valid argument forms, but these are 6 very common ones, and the ones that we're going to be focusing on over the next couple of weeks in the class. So as we go into our section on natural deduction, these will be coming back. Okay, so before moving on, it's important to, well, let me just say that we're going to come back. So as I said before moving on, but actually we're going to move on and we'll come back and talk about this. But it's important to recognize that these are defined syntactically as we have them up here on the board. So just in terms of the symbols and their arrangements. And it's very important to keep in mind that these things here, the P's and the Q's and the R's and the S's, can be any kind of well-formed formula, not just single letters. So if you have tilde R horseshoe V, and you have tilde R and conclude V, that's a version of modus ponens, where P is the tilde R part and Q is V. So it's important to recognize that you could have tildes here. And of course, it's also important to recognize that for example, if I had tilde R horseshoeing, let's say tilde V as my first premise, and the second premise would be tilde tilde V, and the conclusion would be tilde tilde R. So this follows the pattern of modus tollens, where the P term is tilde R and the Q term is tilde Q. And then this says P horseshoe Q, and this right here says tilde Q, because modus tollens says you have to put a tilde in front of whatever the Q term is. And if the Q term is tilde V, I wrote tilde Q over there for some reason. Let me fix that. If the Q term already has a tilde in it, then you have to have another tilde. So tilde tilde V. And then the conclusion says put a tilde in front of the P term. And if the P term is tilde R, then the tilde in front of that is tilde tilde R. So it's important to keep in mind that you may think, tilde tilde V is a weird thing to say. You say, isn't that the same thing as V? It is. But technically speaking, if you just had V right there, So if the second premise just said V and the conclusion said R, then technically speaking, that is not modus tollens. It doesn't follow this pattern because the second premise has to have a tilde in it. Now, of course, we all look at this and we can recognize that in some sense, V is the negation of tilde V, but it doesn't syntactically have negation as its part. So you have to kind of put yourself in the mode of being like a computer. Computers don't understand these things, you might argue, or simple ones. They don't understand that V and tilde V are the same. They follow this pattern. So a syntactic engine is just looking for, do you have a conditional statement? Do you have a tilde in front of the consequent? If so, put a tilde in front of the antecedent. So this would have to be tilde tilde V. Now, if there was only one tilde there, that's also not modus ponens or modus tollens. Sorry, this is not modus tollens because this says tilde V, and so does this. So this is not a tilde of the thing that's right there. So you have to be very careful when you're interpreting these kinds of arguments. Also, the final thing that I'll mention just before we go on is that the order of these premises as they're presented up here doesn't matter. So what matters is the pattern. So if you had something that said A and the second premise said A horseshoe B and the conclusion was B, this is a version of modus ponens, even though the first premise is not A horseshoe B. What matters is that these things here do instantiate this pattern where there's a implication and an assertion of the antecedent of that implication, and then the conclusion being drawn, which is the consequent. So there's nothing important about the order of these premises. What matters is that there's one premise that is a conditional statement and another premise which asserts the antecedent. Over here, what matters is that there's a conditional statement and another premise that denies the consequent. And over here, what matters is that there's two premises that are hypothetical, one of which the consequent is the antecedent of the other. So it's the pattern that matters, not exactly the order of the premises. Okay, so we'll get some practice looking at these as we come up. But remember that these ones are all valid. So if you really wanted to, you could do a truth table on these and they would come out proving that they were valid. But we will also look at invalid argument forms. We will really only focus on two of them. Invalid argument forms are a little bit trickier. This is a D. Invalid argument forms are a little bit trickier, but we focus on two of them. There are many invalid argument forms in propositional logic, but the two common ones resemble modus ponens and modus tollens and disjunctive syllogism in some way. So the first one, excuse me, we call asserting the consequent. These ones don't get fancy Latin names. It's abbreviated AC often. So asserting the consequent goes like this. If you have P horseshoe and Q, and then someone says Q, and then they derive from that P, it's like a version of modus ponens. This is invalid. And the other one that we look at is called denying the antecedent. Denying the antecedent. These are named for what the second premise does. So if you have P horseshoe and Q, and then you deny the antecedent, well, P is false, and then conclude that Q is false, these are both invalid. It's not too hard to see that they're invalid. A truth table would show that they're invalid, obviously, but a simple counterexample would do it too. So if someone said, if George lives in BK, then he lives in New York City. And the second premise says, well, he does. George lives in New York City. And the conclusion would be he lives in Brooklyn. Of course, George may live in Brooklyn, but he might live in Queens or Manhattan or Staten Island or the Bronx. So there are other ways that the consequent could be true. So the consequent being true doesn't tell you that the antecedent is true, because if you live in Queens, so here's George, and he's in Queens. And if George lives in Queens, then it's true that if you live in Brooklyn, then you live in New York. And it's true that he lives in New York, but false that he lives in Brooklyn. And the same is true over here. You could take basically the same conditional premise over here. So you could say, if you live in Brooklyn, then you live in New York City. And the second one, well, is you don't live in Brooklyn, therefore you don't live in New York City. But of course, George living in Queens shows that it's true that he doesn't live in Brooklyn, and yet false that he doesn't live in New York City. So these argument forms are provably invalid. They are bad ways in which to reason, starting off, even though accidentally sometimes, I mean, George may live in Brooklyn, in which case the premise and the conclusions would be true, but not because there's some evidential relationship that exists between the premises and conclusion. That would be like an accident, and therefore these argument forms are invalid. Now, you have to be a little bit careful when it comes to invalid argument forms, because um, there are some argument forms some arguments which look like they may have an invalid argument form, but which are actually valid. So it's not as straightforward as the case is when you are looking at valid argument forms, because anything that can be interpreted as having that argument structure is valid. But in invalid argument forms, it's a little bit trickier. So let's take an example here. Suppose that someone said, well, look, you either, if A wedges B, then B dot C is true. Okay, so, and the second premise, you remember, we're sort of putting something that looks like this. Second premise might say B dot C is true, and the conclusion would be that A wedge B is true. So you might look at this and think to yourself, aha, this is a version of this argument form over here, because the P term could be interpreted as A wedge B. Remember, they could be any well-formed formula. And the Q term might be B dot C. And then this looks like it says P horseshoe Q. And this looks like it asserts the Q, asserting the consequent. And this looks like it's drawing from that conclusion, the P term. So you look at this and you think to yourself, aha, this is an invalid argument because it has the form asserting the consequent and therefore is invalid. However, that would be a mistake, because the argument here is in fact valid. It is in fact valid. And since it's valid, we say that it doesn't have this form. It's not too hard to prove that it's valid. In fact, you could see that it's valid simply because this second premise here, if B dot C is true, then both parts of this is true, which means that in particular B is true. And if B is true, then of course A wedge B will be true, because you only need one part of it to be true. So if up here both of these are true, then this part is true. And if this part is true, then whatever you put on the other side with a wedge is going to be true, because if A is true, then of course A wedge B is true. But if A is false, then it's still going to be true, according to the truth table definition for the wedge. So if you don't believe me about that, you can do a truth table on this. It wouldn't be too onerous. It would just be 8 lines of the truth table, because we have A and B and C. So that's 2 to the 3, which is 8. So it wouldn't be too bad. But you could prove for yourself that this argument is in fact valid, that there are no lines where the premises come out true and the conclusion comes out false. So we say this argument doesn't have that form. Instead, what we would say is that it has this form that we might, since you might say it's P wedge Q, horseshoe, the Q wedge R, and the second premise says Q dot R, and the conclusion is P wedge Q. Okay, so this is actually the form that the argument has, and really you could get rid of this first premise here and say this is the form that the argument has, and this is just kind of an extra premise hanging around to confuse us. So if Q dot R is true, then P wedge Q is true. Okay, so if that's confusing to you, then join the club. That's the way this stuff works. But you can rest assured that when it comes to exams and homework assignments in this class, that we won't sneak any tricky ones like this in, so that if something looks like it has the form of asserting the consequent, it will. But I just need you guys to be aware that in real life, it's not quite as simple as simply saying, aha, this looks like it has that form, therefore it does, because there may be cases where it comes out valid for some other reason, like, for example, because of some subset of the premises guaranteeing the conclusion, so that it's kind of an illusion that it has this form over here. And of course, the same could be true with this denying the antecedent. There may be something that looks like it has the form of denying the antecedent, which we would say doesn't really. So one example that's kind of artificial, but I think would work is if you say, well, look, if you have A and it horseshoes B dot tilde B, so there you go. And the second premise would say tilde A, and the conclusion would say, therefore, tilde parentheses B dot tilde B. And once again, it looks like you have the P term being A, and the Q term being B dot tilde B. And then this says P horseshoes Q, and then you have tilde of the P, and then you have tilde of the Q over here. So it does look like it has the form of denying the antecedent. But of course, this argument is valid. It's valid for a different reason than the one before. The reason why it's valid is because the conclusion here is a tautology. So B dot tilde B is a contradiction, and the denial of that is a tautology. So the conclusion is always going to be true. So in particular, it can't ever be the case that the premises are true while the conclusion is false. A truth table would verify this, by the way, if you really wanted to do one. It wouldn't be too hard. It would just be 4 lines of the truth table. But you can kind of already see that B here can either only be true or false. So reversing that, this is always going to be false because these are contradictory. And then so the conclusion is always going to be true. So there's no way to make the premises true and the conclusion false if the conclusion is always true. So this is another kind of tricky example where you have arguments that look like they follow this pattern, but they really don't, according to us, because we adopt the convention that says that if the argument is valid for some other reason, then it's incorrect to say that it has this invalid argument form. So invalid argument forms are a bit slippery. There is a possibility that you could see something and go, oh yeah, that looks like it has that form. But we would say, no, it actually doesn't. It has some other form. Whereas with valid argument forms, you don't ever have that problem. There are no arguments that look like they have a valid argument form, which you say, no, they must be interpreted in some other way. So this is only kind of a tricky thing with invalid argument forms. So that's just in case anyone cares about actual logic. But for any kind of, in my class that I'm teaching, any kind of work that we're going to be doing, if you think that something has one of these forms right here, then we kind of guarantee that it does. Okay, so let's go ahead and look at the textbook then. I have it pulled up over here. There we go. I have it pulled up over here so that we can do the exercise. And this is from section 6.6 here. It says, interpret the following symbolized arguments in light of the 8 argument forms presented in this section. So that's the 6 valid ones and 2 invalid ones. modus ponens, modus tollens, pure hypothetical syllogism, disjunctive syllogism, and the two dilemmas, constructive and destructive. And then also, in addition, denying the antecedent and asserting the consequent. So we have 8 of those argument forms. Keeping in mind that's not every argument form that exists, that's just some common ones. So it says interpret these in light of that. In some cases, a symbolized argument must be rewritten using commutativity or double negation before it becomes an instance of one of these forms. So what does that mean? Well, we sort of talked about that a little bit already. But double negation is this idea that if you have a letter like P, then that's logically equivalent to tilde tilde P. So you could prove this, right? The truth table for this is just that. And the truth table for this, the tilde is going to reverse those. And this tilde is going to reverse those so that these have exactly the same truth table, so that P is logically equivalent to tilde tilde P. And when two things are logically equivalent, we say they're interchangeable. They have exactly the same meaning. And you could replace one with the other without any loss of meaning. Now, commutativity is the same thing. Commutativity is a rule that says that you can change the order of disjunctions or conjunctions. So if you have A wedge B, then that's logically equivalent to B wedge A. Allergies are coming. I feel a sneeze. Uh-oh. Excuse me. I haven't quite fought off the the allergies. Okay, so to commute is to go back and forth. Like I commute to work and then I commute home. I go to work, I come back. So to commute in logic is just to go back and forth, changing here. And you could do the same with these. So we saw that this actually causes some problems when we looked at logic and ordinary English, like when we say, Alice went to the beach and broke her arm versus Alice broke her arm and went to the beach. People think they mean different things, but logically they're equivalent. So we're not really going to focus too much on the conjunction version, but the disjunction version is important. And the reason it's important is going to be because some of these examples down here, like for example, if you look at number 13, number 13 says the first premise is P wedge S, and the second premise is S. Oh, sorry, that's tilde S right there. So P wedge tilde S, and the conclusion is P. So this kind of has a wedge in it, so it looks like it should be a disjunction. But of course, disjunctive syllogism says that you have to have P wedge Q and then a tilde in front of the P part, and then you get to infer that Q. So this looks like the first premise says P wedge Q, as long as you interpret P to be capital P and Q to be tilde S. Okay. So that looks great. But then actually what you would recognize is, well, if you want to conclude that P, this would have to be commuted. So we would actually have to take that first premise and rewrite it as tilde S wedge P. And then the second premise here says S, and the conclusion says P. And that tells us that we really want to think of these things down here as the P part being tilde S and the Q part being capital P. So you could assign these things any way that you want, that's useful for you. So if we're thinking of the P thing as tilde S and the Q thing as capital P, then this first premise now says P wedge Q. And the second premise, though, doesn't say tilde of the P part because the P part says tilde S. So then you would have to use double negation and write tilde tilde S. And now you have a tilde in front of the P part, and you're allowed to conclude that Q. So in order to interpret this as disjunctive syllogism, this is number 13 over here, by the way. In order to interpret number 13 as disjunctive syllogism, you would have to rewrite it using the commutativity rule, which says reverse the order of the disjunction. You can't do it with horseshoes, only disjunctions and conjunctions, because A horseshoe B is not the same as B horseshoe A, as a truth table would show you. Okay, so you have to keep that in mind. Sort of jumped ahead there, but that's okay. So let's go back and look at these things starting from the beginning. So this first one says N horseshoe C. The second premise is tilde C. The conclusion is tilde N. So we see that there's a horseshoe in the first premise. We think about which rules we have, or excuse me, which argument forms we have that have the horseshoe in it, and it's modus ponens and modus tollens. So modus ponens says you have P horseshoe Q, and then you say P, so you get Q. And modus tollens says you have P horseshoe Q, and then you deny Q, so you get a denial of P. And you look at this one, you think, well, which one does this look like it fits? And we have a tilde here, okay, a tilde of C. So it looks like our P term is N, and our Q term is capital C. And the second premise says a tilde of C, and the conclusion is a tilde of N. So this one here is modus tollens. Does that make sense? Okay, so moving on to number 4 down there. Number 4, we have this S horseshoe tilde P dot tilde S horseshoe D. Then you have S wedge tilde S, and the conclusion is tilde P wedge D. So this one has a dot of 2 horseshoes. So that looks like it's going to be either constructive or destructive dilemma. So remember that this constructive version is P horseshoe Q dot R horseshoe S. And then you have a P wedge R, conclusion of Q wedge S. The destructive version, so that's the constructive, if I can just use the same premise here. The destructive version says tilde Q wedge tilde S and concludes tilde P wedge tilde R. So which one is this? Well, if we interpret the P term as S and the Q term as tilde P and the R term as tilde S and the S term as D, then this first premise says P horseshoe Q, tilde P is the Q thing. And this one says R horseshoe S, tilde S is the R thing. And then what's this say? Well, it just says P wedge R. P wedge R. So this right here, therefore, is a constructive dilemma. So remember, if you're having problems with this, it takes some practice as you're doing the rest of these problems. If you get stuck, you can always send me an email, leave a comment on the video. For those in the class, you can come to my office hours. For anyone else who may be watching this, I'm happy to answer questions about this stuff. Even if you aren't in the class, as long as the questions are about this stuff or something related to philosophy, I'm okay with discussing it for the most part, some exceptions. Okay, so that's constructive dilemma. All right, well, let's look at number 7 here. Number 7, it's looking kind of similar because we have this first premise that has a dot of 2 horseshoes. So it's either a constructive or destructive dilemma, most likely. I mean, it's not guaranteed because there could be things that look like it that aren't. But let's figure out what's going on here. So to make this first premise fit into the constructive dilemma or destructive dilemma format, you would have to interpret P as being E and Q as being N. There are other ways to interpret this. Like you could take this whole thing to be P. You could take just this to be the P part. So there's some freedom here, which kind of trips people up. It's a little bit of a skill you have to learn. But when you're looking at your argument forms and trying to interpret this, you want to do what makes sense and what's going to help you. So if we interpret things this way, that's okay. Oh my gosh, I'm not good at the handwriting. So here, this would be a tilde K. So if you interpret things this way, then this says P horseshoe Q and R horseshoe S, okay? Now, what's this? Tilde n is a tilde of the p part. And then you have k over here. But it's not a tilde of tilde k. So you would actually have to rewrite this second premise as tilde n wedge tilde k, and this conclusion as tilde e wedge tilde l, using double negation, just substituting those in. And then this becomes destructive dilemma, but only after you rewrite it. So the correct answer is that once you rewrite it, it's destructive dilemma. Okay. Hopefully this is making some kind of sense. Um, it's hard to tell when I'm just sitting here talking to myself. All right, going on here to number 10. So we have F horseshoe O, tilde F, therefore tilde O. So interpreting P as being F and Q as being O, then this first premise says P horseshoe Q, F horseshoe O. And the second premise is a tilde of the P part. So the one that looks like that has a tilde of the P part and concludes tilde of the Q part is denying the antecedent. So this is an invalid argument form denying the antecedent. Okay, very good. We don't have to rewrite anything there. All right, so that was number 10. Then going over number 13, we already did that. Disjunctive syllogism, once you rewrite the premises, even if you can tell that they look this like it fits the pattern, you have to rewrite the premises for them to fit the pattern. Okay, so number 16, fairly straightforwardly, looks like asserting the consequent because here's H and there's the horseshoe. So if you take P to be tilde G and Q to be H, then this says P horseshoe Q, Q, therefore P, which is asserting the consequent. So this is another invalid argument form here. All right, good. So now we're just getting the skills to recognize these once they're in symbolic form. In the next section, we'll translate them. And is that something I need to erase? We'll translate some stuff into English and then try to interpret them in terms of the forms. So here, this kind of looks like it could be pure hypothetical syllogism. But there's all horseshoe statements here. But let's look at what we have and see if it makes sense. So X horseshoe tilde F, W horseshoe tilde F, therefore W horseshoe X. Does that really follow the pattern for pure hypothetical syllogism? Well, let's see. If you take P and have it stand for X, and you have Q being tilde F, and R being W, then in fact, this argument has a different form. It says P horseshoe Q and R horseshoe Q, therefore P horseshoe R. So that's not pure hypothetical syllogism. The pure hypothetical syllogism, remember, says P horseshoe Q and Q horseshoe R, therefore P horseshoe R. So this second premise is reversed. This says R horseshoe Q instead of Q horseshoe R. So this is the pure hypothetical syllogism. This one, we didn't give a name to it, and the instructions up above, oops, the instructions up above say those that don't have a name are invalid. So that's a little shortcut. Now, obviously, if this were a test or something, I'd make you prove that it's invalid. And it wouldn't be too hard to prove that this argument form is invalid using a truth table. You could do it fairly quickly. So if you had your P horseshoe Q, and then your second premise was R horseshoe Q, and your conclusion was P horseshoe R, then you're going to have to do 8 lines of the truth table. We can do this really fast for fun and for further practice. So we're going to have our 8 lines of the truth table, and we know what to do with these 8 lines now. Under P, we're going to write 4 trues and 4 falses. And under Q, we're going to write our alternating 2 trues and 2 falses. True, true, false, false. Okay. And then for R, we're going to alternate true, false, true, false, true, false, true, false. Now we just do the computing part, P horseshoe Q. So it's going to be true, true, false, false, false and true is true. And oops, button is getting pressed here. True. Okay, so now we circle this as being the main operator. Down we go. Okay, now our horseshoe Q, here's Q right here. I could rewrite it, but I'm going to be lazy and not rewrite it. So true and true makes true, false and true makes true, true and false makes false, false and false makes true, true and true, false and true, true and false false. So this one's easier to circle for me. Okay, now P horseshoe R, here's P and here's R. So true and true make true, true and false make false, true and true make true, true and false make false, false. These are all false. So that means it's all going to be true. A little shortcut we can take. So now then, looking at every case where we have the premises be true. So line 1, we have true, true, true. So that seems fairly good so far. But line 2, true, true, false. So line 2 shows that the premises can be true and the conclusion can be false. And then we look down here. Here's one where they're true. Here's one where they're true. So there are lots of lines where the premises come out true and the conclusion comes out true, but there's one line where the premises are true and the conclusion is false. So it is possible for the premises to be true and the conclusion to be false. Therefore, this argument form, this one here, is invalid. So the book is correct. And now we know anytime we see something that looks like this, we can ask ourselves, is it invalid? Now, remember, we could come up with a case where I could think of an example where it looked like it had this form, but it was really valid. Remember our discussion of that a second ago? We don't need to do that right now, but it is possible. So you do have to always sort of keep in the back of your mind that simply because it looks like it has that argument form invalidly doesn't mean necessarily that it does. So that's a little bit unfortunate, but that's how things go. Okay, so that's that section. So now we only have to do the next section. The next section is basically exactly the same, but we have this command to translate the statements into symbolic form before we do the thing that we just did. So let's go ahead and do this now. So number 1 says a Boeing 757 crashed into the crashed into the Pentagon on September 11, 2001. Somewhat of a weird example. Only if 2 giant engines were found outside the building. Okay. It is not the case that 2 giant engines were found outside the building. Therefore, a Boeing 757 did not crash into the Pentagon on 9/11. All right. Okay, so a bit of a weird example, but nonetheless, we can analyze it. So here we have the word therefore, so we know what the conclusion here is. We see the word only if here, which means that's a horseshoe. So we know this from before. So the first premise here says if we use B to stand for a Boeing 757 crashed into the Pentagon on September 11th, and G for 2 giant engines were found outside, then we simply have B horseshoe G. The second premise here says it is not the case that G, so that's tilde G. And the conclusion is it is not the case that B. Okay, so now if you interpret the P term as being B and the Q term as being G, then this looks like we have modus tollens here. Modus tollens, remember, says P horseshoe Q and tilde of Q, then you get tilde of P as a result. And so we have P horseshoe Q, tilde of the Q thing, therefore concluding tilde of the P thing. So that in fact is modus tollens. All right, so that one's fairly straightforward. Remember, I don't pick this book because I endorse the examples that are used. I think that's a weird one. Okay, but nonetheless, so moving on to number 4 here. Um, Either the wealthiest people are the happiest, or it is not the case that money can buy everything. The wealthiest people are not the happiest, therefore, money can't buy everything. Okay. So the first premise, we have W and M for wealthiest people are happiest. That's W. And money can buy everything. That's M. So the first thing says either W or tilde M. The second premise says the wealthiest people are not the happiest. And the conclusion is therefore money can't buy everything. So we're looking at this and we know there's only one argument form that has the wedge as its main operator. That's disjunctive syllogism, which looks like this. P wedge Q tilde P, therefore Q. And we're looking, this is my M right here. I know my handwriting leaves much to be desired. Okay, so looking at this, if we interpret the P term as being W and the Q term as being tilde M, then this says P wedge Q, tilde M being Q. And this says, oh, that's supposed to be a W. Oh my gosh, my own handwriting is tripping me up. Yeah, that's W. This says tilde of the P term, and the conclusion is simply Q, which is tilde M. So this, in fact, is disjunctive syllogism. Okay. Very good. Nicely done. All right, so there's not too many more of these. We're almost done for today. Let's go ahead and go through them. Number 7, nanothermite was present in the, oh God, another one. Okay, in the debris from the World Trade Center. But if that is so, then the buildings were brought down by a controlled demolition. Who wrote these? A conspiracy theorist? Remember, I guess it's good. It's good to have these kinds of controversial examples because it kind of points out that you don't have to agree with someone in order to analyze their arguments, and you don't want to. You want to see, well, okay, so is the argument valid? Then you want to object to the premise, maybe if you don't agree with the conclusion. Like in that first one, the first premise seemed false to me, but that's okay. We don't need to worry about that. All right, so we can see there's the word therefore here, and we have N and B. So N would be nanothermite was present in the debris from the World Trade Center, and B would be the buildings were brought down by a controlled demolition. So the first premise here says simply N. Now this, if that is so, confuses people sometimes. But if that is so, really is referring back to the first statement here. So they're saying if N, then they were brought down by a controlled demolition. And therefore, the conclusion of this is that B is the case. So this looks like it's a version of modus ponens. If you take P to be N and Q to be B, then the second premise says P horseshoe Q. And the first premise says, well, P is true. And the conclusion is the Q part there. Remember, the order of the premises doesn't matter here. So what matters is you have one conditional statement and another one which asserts the antecedent. So therefore, this is modus ponens. All right. So maybe this first premise is false. I don't know much about the conspiracy theories about 9/11, but I know that people do have them. Okay, oops. Okay, so moving on along here to number 7, then going down to number 10. So this one looks more complicated. We have L, A, C, and F. So let's see here. If limits are imposed on medical malpractice suits, then patients will not be adequately compensated for their injuries, semicolon. But if the cost of malpractice insurance continues to rise, then physicians will be forced out of business. Limits will not be imposed, and the cost of malpractice insurance will not continue to rise. Therefore, patients will be adequately compensated and physicians will not be forced out of business. Okay. So we have L for limits are imposed on medical malpractice suits, and A for patients will be adequately compensated. If so, that first premise, the first part of it anyway, says L horseshoe tilde A. We know that that's the first part because the semicolon people don't really know about what to do with commas and semicolons in English. But in logic, they represent grammatical issues having to do with main operators and where parentheses go. So a semicolon really means these ideas are related, they're separate, but not like fully separate sentences. So this is one thought in a sense. And the semicolon but is treated as introducing a and. So we would treat that as a dot. And so on the other side of it is this other conditional statement. If the cost of malpractice insurance continues to rise, then physicians will be forced out of practice. So that's C horseshoe F. C horseshoe F. Okay, so this it looks like they're trying to do a constructive dilemma. So we'll see what the second premise says. It says limits will not be imposed and the cost of malpractice will not continue to rise. So that's tilde L and tilde C. And the conclusion is therefore, patients will be adequately compensated and physicians will not be forced out of business. Okay, so they're trying to trick you with this one because it superficially resembles the constructive dilemma, but the second premise is not a dilemma, it's a conjunction. So in order for it to be a dilemma, it had to have a wedge right there. So if it said tilde L wedge tilde C, and if the conclusion was a wedge tilde F, then it would start to look like a constructive dilemma. But actually, if you notice, this is a tilde of the antecedent. So there's even if there were wedges there, this would still be not a constructive dilemma because it would either need to be negations of the antecedent, of the consequent, or simply assertions of the antecedent. Anyway, so this is not a constructive dilemma. It's not a destructive dilemma. Therefore, this argument is invalid. It has that form. We could prove that it's invalid if we really wanted to, but I don't feel like doing. There's 4 here, so that would be 16 lines of the truth table. It's kind of annoying. But they told us if there's no name for it, if it's not one of the ones we recognize, then it's simply invalid. So that's a shortcut for us there. Nice to know. Okay, so how many more of these do we have today? Looks like only 3 more. Okay, so number 13. Number 13 says, if we want to arrest criminals, then police must engage in high-speed chases. But if we want to protect motorists, then police must not engage in high-speed chases. Since police must either engage or not engage in high-speed chases, either we will not arrest criminals or not protect motorists. Okay, so this is following a similar pattern here. We have this semicolon and but right there, so that's going to be a dot. And we have 2 horseshoe operators. So our first premise here, the first one says, if we want to arrest criminals, then police must engage in high-speed chases. And the second thing says, if we want to protect motorists, then police must not engage in high-speed chases. The second premise here says, since they must either do it or not do it, so you either get E or not E, the conclusion of this is that you either will not arrest criminals or not protect motorists. Okay. So this one does look like it's one of our dilemmas here. We have the conjunction of 2 horseshoes. We have wedge statements in the second premise and conclusion. So here we have E and here we have tilde E. So this looks like if we rearranged it, if we rewrote the second premise as saying tilde E, wedge tilde E, and the conclusion would be leaving it the same, tilde P. And the first premise, leaving it the same, A horseshoe E dot P horseshoe tilde E. Then now this second premise is a negation of that consequent. And now this second disjunct of our disjunction is a negation of that. So now we have destructive dilemma. Now, of course, what's interesting is we could have reversed the and statement here if we wanted to. So we could have rewritten the first premise as P horseshoe tilde E, and then put a dot and A horseshoe E, because this conjunction could be commuted that way. And then we could have left the second premise in the same order, applying double negation like that. And then the conclusion being tilde A wedge tilde P. And so this is also destructive dilemma. So whether you want to commute the second premise or commute the first premise is really up to you. The book only told us about commutivity for disjunction, but I told you, oops, sorry. Didn't mean to do that. I told you about commutivity for conjunction, so it would have worked. Either way, once it's rewritten, this is destructive dilemma. So remember, it's important that it gets rewritten that way. This is something you absolutely will have to keep track of as we go through these things. Okay, so number 16, two propositional letters. It says if congressional districts are gerrymandered, then minority voters will make no difference. So that's C horseshoe M. And minority votes will make no difference. That's M. And therefore congressional districts get gerrymandered. Now, of course, some people might translate this. So I took C. Sorry, I took M to be minority votes will make no difference. Of course, you might have taken M to be minority votes will make a difference. And then you might have translate this as C horseshoe tilde M. They'll make no difference. They will not make a difference. And then this would be tilde M here. And then this would be C. Okay, so you could do it either way. The reason why I chose to do it this way is because this is already an affirmative statement. It says they will make no difference, which is an affirmative statement. But sometimes people get confused about that. And technically, I would count either one as fine as long as you had a key that verified what you were doing. But let's see if it makes a difference to the answer. So for this one up here, if you took the P term to be C and the Q term to be M, then this says P horseshoe Q. The second premise says Q, and the conclusion is P. So that is asserting the consequent. Now, if you did it this way down here, you would have to take the P term to be C and the Q term to be tilde M. Then you have P horseshoe Q and an assertion of Q, and the conclusion being M. So either way you get it, it's going to be asserting the consequent. Okay, so when it comes to tests and that sorts of things, as long as I can make sense of your key, I give you at least partial credit, if not full credit, depending on what you do. But if you translated it one way versus the other, that's why it's very important to have a key where you say what you take these capital letters to stand for, so that we can all agree and understand what you're doing. All right, so then the last one here that we're going to do, remember, we'll go over the non-starred ones in class after you do the assignment. So we have S, C, and I. The first premise says, well, let's assume it's a premise. If sea levels rise 20 feet worldwide, then coastal cities from New York to Sydney will be inundated. So it looks like S is sea levels rise 20 feet worldwide, and C is coastal cities from New York to Sydney will be inundated. So that's first premise simply says S horseshoe C. This says if ice sheets on Antarctica slip into the sea, that must be I, then sea levels will rise 20 feet. So that's if I, then S. Therefore, if ice sheets slip into the Antarctica, if the ice sheets on Antarctica slip into the sea, then coastal cities from New York to Sydney will be inundated. Okay, very good. Now, we only have one argument form that has all the horseshoes. So if this is a valid argument form, it's got to be the one that is the pure hypothetical syllogism, which says if you know that P horseshoes Q and Q horseshoes R, then you get P horseshoe R. Um, so looking at this, the crucial thing is that you have these connecting, that there's a one consequent that is showing up in the antecedent of the other conditional statement. And here it does look like you have that. So here you have S horseshoe C, and over here you have I horseshoe S. So if you take P to be I and Q to be S, and R to be C, then uh, then you can see, in fact, that this is a pure hypothetical syllogism. So this is a substitution instance of the um, pure hypothetical syllogism. Therefore, this argument is valid. Now, just before we end today, what would happen if you didn't do it this way, but instead just kind of didn't think about the argument forms first, but just kind of launched into this and said, look, I'm going to take this thing right here. I'm going to take P to be S, and I'm going to take Q to be C, and R to be I. And then you say, well, look, what if this has the first thing says P horseshoe Q. So it says P horseshoe Q, given that P is S and Q is C. And the second one says R horseshoe Q, R horseshoe Q. R, sorry, it doesn't say R horseshoe Q, does it? No, it says R horseshoe P. So the second premise says R, which is I, horseshoe P, which is S, R horseshoe P. And then the conclusion of this would be I, which we're taking to be R, horseshoeing C, which we're taking to be the Q term. So now, if you did it this way, you still have something which follows the pattern of hypothetical syllogism. It's just not written in that canonical way. Because here we have R horseshoeing P. So now this says P horseshoes Q. So it still follows the pattern whereby the consequent of one conditional statement is the antecedent of another conditional statement. So it doesn't follow that traditional canonical form, but you can still see that it's supposed to be a pure hypothetical syllogism. And the conclusion says that you get the R going to Q. So even if you didn't recognize that the second premise is really that first premise, so that these are out of order, even if you didn't recognize that, you would still be able to recognize the pattern if you understood it at the abstract level. Because what is important is not these lowercase statement variable letters, but rather the way that those things allow you to see the underlying pattern. So sometimes these argument forms are compared to like the skeleton. So like, you and I have a skeleton that is roughly very similar, but on the outside, we look very different. You may have brown eyes, I have blue eyes, I have this color hair, you have that color hair, you're taller, I'm shorter, etc. So, but underneath our skeletal structure is very much similar, not identical, but similar. So the analogy is not perfect, but still, if you think of this as like the skeleton, then what these things over here are like the flesh that you could put on the skeleton. What matters is the structure that it has. So which thing counts as the femur bone and which thing counts as the elbow, the tibia, whatever, depends on its relationship to the other bones, not exactly its structure or something like that. Okay, so maybe the analogy is a little bit strange, but it works somewhat. So it's important that you understand the hypothetical syllogism isn't simply this arrangement of P's and Q's, but that those allow us to see the structure that is there, whereby you have two conditional statements, one of which has the consequent, which is the same as the antecedent in the other. And then that allows you to kind of join the chain and link the two antecedent and consequence of the other one in this way. Okay, so that's probably enough for one day. We will talk about this much more in class. And as I said before, if you're in this class and you have questions, come to my office hours or email me. And if you're not in this class and you have questions about this material, I'm also happy to discuss it with you as long as it's relevant to the class or to logic, generally speaking, or philosophy, generally speaking, since the class is logic and philosophy. All right. Anyway, one does tend to ramble, doesn't one?